This conference will now be recorded.
Hi, and welcome to Aspire Test Prep's math lesson on 90 minus x as the complement. Aspire Test Prep offers one-on-one online SAT and ACT instruction for all areas of those tests, and we also encourage you to support on Patreon our efforts to share world-class SAT instruction with everyone for free. Let's go ahead and get started. So on the SAT, you'll see the phrase 90 minus x thrown around kind of randomly. And here we're going to kind of tell you what it means. So if you have a right triangle, this being the right angle right here, the whole triangle has to add up to 180 degrees. The three angles of the triangle have to add up to 180. So that means that if the blue one is 90, then these two green ones have to also add up to 90 to make the whole triangle equal to 180. So in math terms, we call these two angles complementary. Complementary refers to two angles that add up to 90, and by the way, supplementary refers to two angles that add up to 180. So if these two green angles add up to 90, let's just imagine for a second what that means. That means that if this angle were 60, the other angle would be 30. Or if you want to use more extreme numbers, if this angle right here were 80, and this angle right here would be 10, right? Because the two angles need to add up to 90. Now, if I had 60 for one of them, how am I getting 30? Well, because I have 90 and I'm subtracting away the 60, that gives me the 30. Or I have 90 and I'm subtracting away the 80 and that gives me 10. So the way to kind of figure out the pair of a complementary pair, the other angle, is by subtracting from 90. So if I didn't know what the other angle was, and I wanted to find, let's say I wanted to find this pink angle, I wanted to find an expression for it because x means we don't know what it is. But if I want an expression for that pink angle, I can say, well, I know the other one is 90, and I'm going to subtract that one, just like we did when we knew the number. So if we knew that it was 60, we will subtract the 60. If we knew it was 80, we'd subtract the 80. And if we know it's x, we just call it 90 minus x. So according to this line of thinking, if one angle is x, we can call the other angle 90 minus x, and the reason is because they're complementary. They add up to 90. A way to kind of test out this idea is to say, okay, what does x plus 90 minus x add up to? Well, if I did this, the x and the negative x would cancel, leaving us with 90. So that's the idea of 90 minus x. When you see that being thrown around, it's a reference to the idea of the other angle in a complementary pairing. So in this particular question, we're being told, okay, this one's x. The tan of 90 minus x equals something. Okay, so these two yellow angles we know are complementary because the two yellow angles plus the green angle have to add up to 180. The three angles of a triangle add up to 180. So the two yellow ones are complementary. Therefore, if one of them is x, we can refer to the other one as 90 minus x. So this orange statement right here is saying the tan of this angle equals 10 over 24. So now that we know we're talking about that angle, we'll go ahead and say, okay, well, trigonometry, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. So trigonometry has everything to do with where you're standing. So we're standing at this orange angle, and the opposite of that angle is this one right here. So we'll call it opposite. In a right triangle, the hypotenuse is always across from the 90-degree angle. So the hypotenuse is right here. And the one left over is the adjacent. So right now, based on standing at the orange angle, we know where the opposite, the adjacent, and the hypotenuse all are. So the tan of that angle we're talking about is 10 over 24. So the opposite over adjacent for that angle, opposite over adjacent, 10 over 24. So we have a 10 here and a 24 here. Now we can use Pythagorean theorem, a squared plus b squared equals c squared. 10 squared plus 24 squared equals c squared, and we can use that to find the length of the hypotenuse. So this is 100, this is 576, so c squared equals 676, and the square root of that is 26. So using Pythagorean, we found out that this side has a length of 26. Great. So using all our trig stuff and our 90 minus x and all that stuff, we figured out that the hypotenuse was 26. Now, why am I erasing the words opposite and adjacent? I'm not going to erase hypotenuse because the hypotenuse is always the hypotenuse. But right now, we just know that these three sides are 10, 24, and 26 in length. And the angle we're talking about now is not the 90 minus x angle. It's not the orange one that we were working on before. It's this blue one. It's the one that's labeled x. So if we're standing at that blue angle, then we can go ahead and say, okay, well, the opposite of that blue angle is this one. We'll call that opposite. Hypotenuse is still the hypotenuse. That never changes. So the leftover one is now the adjacent. So if we're standing at the blue angle, the x, as opposed to the orange angle, the 90 minus x, then we can now see that the opposite and adjacent have kind of like switched places. So the tan of that blue angle, opposite over adjacent, standing from the blue angle, is now 24 over 10, because the opposite is 24, the adjacent is 10. So tan of x is D right here. Now, by the way, for all of our videos, the best way to take advantage of them is to pause the video at the beginning of one of the problems that we show on the screen. See if you can answer the question on your own, and if you need help, just go ahead and watch our explanation. So the second one here, similar question, sine of 90 minus x is 8 over 10. What's the value of tan x? So once again, if this yellow one's 90, that means that these two green ones add up to 90 also, because the whole triangle has to add up to 180. So the two green angles are complementary. And if they're complementary, that means that if I can call one of them x, I can call the other one 90 minus x, because x plus 90 minus x adds up to 90. So now we know that we're standing at this purple angle right here, because it says it's the sine of 90 minus x. So in trigonometry, everything is where you're standing. So we're standing at the purple angle. Standing there, we have our hypotenuse. That's always the case. Hypotenuse is the hypotenuse. Nothing can change that. But going opposite of the 90 minus x, we call that one opposite. And the third one left over that's not opposite or hypotenuse is the adjacent. So the adjacent angle is right there. And the sine of that angle, opposite over hypotenuse, in SOHCAHTOA, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So the sine is the opposite over the hypotenuse, and that's 8 over 10. So in other words, this one's 8 and this one's 10. So now we can use Pythagorean. We can say a squared plus b squared equals c squared. And one of the legs is 8. The other one is the one we don't know. And the hypotenuse is the c. Okay, just expanding out the 8 squared and the 10 squared. Take away 64 from both sides. Square root of both sides. And you have a 6 right there. So now we know that this side is equal to 6. So the question is saying, okay, well, what's the value of tan x? Okay, so if we're saying tan of x, we're not standing at the purple angle anymore. We're standing at this orange angle. And what's that going to change? It's going to change the location of adjacent and opposite. Hypotenuse never changes. But if I go opposite the orange angle, then I call that opposite. Hypotenuse is still hypotenuse. So the third one left over is the one we call adjacent. So what I'm saying is that by switching from the purple angle to the orange angle, the names opposite and adjacent in trigonometry switch places. So what's the value of tan of x, tan of the orange angle? Well, tan is opposite over adjacent. So it's 6 over 8, which, by the way, also simplifies to 3 over 4. So the answer for this one would be A. Going to the next question. This question is a little different. It's got no diagram to it, but that's not a problem if you're seeing the reference that's being given, because you've got a cosine here and sines in the answer choices. You've got x and you've got complementary in the answer choices. So this is a reference to an idea. And one of the biggest things you can ever notice about the SAT, particularly on the math side, but also on the other sides as well, is that there are a lot of references to ideas that you're supposed to kind of light up when you see that reference. Think of them as code words. This is a reference to the idea that cofunctions of complementary angles are equal. So we'll definitely be making a video on this one really soon. But the idea of this is if x plus y equals 90, another way to say that x and y are complementary, then the sine of x is equal to the cosine of y, or the other way around. The cosine of x is equal to the sine of y. So x and y add up to 90. The sine of one equals the cosine of the other. That's the rule. So another way to think of this rule is as a checklist. Cofunctions, complementary, and equal. 3 things to look out for. So I do have cofunctions because I have sine and cosine. I do have complementary, x and 90 minus x. So therefore they're equal. If the cosine of one of them equals b, then the sine of the complement must also equal b because they're equal. So the answer to this one is C. It fits the idea that the cofunctions of complementary angles are equal. So question number 4 now. If the sine of x equals b, which of the following is true? Well, it's the same question, just slightly changed. Cofunctions of complementary angles are equal. So, do we have cofunctions? Cofunctions is the idea of sine and cosine. It would also be tan and cotan, or secant and cosecant. So yes, we have cofunctions. Check. Do we have complementary? Yes, because we have x and 90 minus x. And in this video, we're talking a lot about how those expressions are equal to each other. So the one that seems to have everything we're looking for is choice D, because you've got, in choice D, you've got sine and cosine cofunctions, x and 90 minus x complementary, and so therefore they're equal. If one of them equals b, the other one equals b. That's this. So if we think of the cofunctions of complementary angles are equal, if we think of that rule as a checklist, choice D gives us everything we need for the checklist. So once again, Aspire Test Prep offers online one-on-one instruction with a great tutor, and we can get you ready for the SAT. We've helped lots of students get into all of the world's top colleges and boost their SAT and ACT scores tremendously. And we also ask that if you like this video, you can support our efforts to bring world-class SAT and ACT instruction to the public, and you can support those efforts on Patreon. And if you do, we really appreciate it. Have a wonderful day.